Assalamualaikum and hello everyone. We are from Group 2, Section 13. We will present about path and circles, electronic circuit designed by using Hamilton circles. We have four members including me. My name is Rahina Puteri and our next member are Nuri Atila, Nurin Atira and lastly Fazlin Harani. The introduction about the path and circuit electronic circuit design using Hamilton circuits project represents a foray into a dynamic intersection of graph theory and electronic circuit design. This project explores the application of Hamilton circuits, a concept from graph theory as a potential solution to enhance the design and organization of electronic circuits. There will be a detail in the design and implementation of the Hamilton circle identification algorithm, provide insight into its functionality and present the results obtained from applying the algorithm to a sample electronic circuit. The background research explores the current state of electronic circuit design and the emerging trends in system miniaturization, integration, and complexity. As electronic devices become smaller and more powerful, the need for efficient circuit layouts becomes critical, and innovative approaches rooted in mathematical models like Hamiltonian circuits become increasingly relevant.
Okay. Next, we proceed to the literature review. My name is Ajrabiti Muhammad Hamizi and my meeting number is CI22096. In this Hamilton cycle, offers existing potential for optimizing circuit design. It's minimizing wire length, crosstalk, and board area, leading to more reliable, efficient, and compact circuit. Next, for challenges, it's finding optional cycle in computationally complex, and then integrating with existing design constraint requires careful consideration. And for the further directions, develop advanced algorithm and heuristic for better application, and explore new application, seamless integration with design tools. Okay, so for the overall, Hamilton cycle hold immense potential to revolutionize electronic design, and then it's paving the way for smaller, faster, and more effective, efficient in devices. Okay, next is methodology. So in this project path and cycle, the first one is shorten connection, which is less wire means less interference, leading to cleaner signal and faster performance. The second one is compact layout. Compact layout is squeeze more functions into smaller space and opening doors for miniaturization. And then the third one is synchronized clocks. Synchronized clock price coordination for better timing and efficiency, especially in high speed circuit. Okay, the fourth is picking the right algorithm, and different circuit, different needs. We choose to the Hamilton cycle finder that best suit to the task and for our project. And the fifth is accurate mapping. Okay, accurate mapping is transforming the circuit into a network where each component become a node and connecting connections become path. And then the sixth is meticulous optimization. The system analyze each cycle, considering factors like power consumption and wire length to find the absolute best option. And the last one is seamless integration, which the chosen cycle gets woven into the circuit design, ensuring a peak for the performance.
For result and discussion, we have a three example. For figure one, we have five vertex of Hamilton circles. So for figure one, we will pass two light bulbs. So based on the diagram above, we can sum up the directions. We we will start with vertex A, B, C, and will be A end with A. So with the total weight for the calculation is a 3 plus 2 plus 2 plus 3 plus 3 plus 4 and plus 2. So the total weight for figure 1 is a 20. For figure 2, we have 4 vertex of Hamilton circles. So in electronic circuit, we must pass on both sides of the battery. So in figure 2, we need to calculate the weight 2 times at each vertex. So based on the diagram above, we can sum up the duration. Will be start with vertex A, B, D, and will be end with vertex A with the total weight. Weight for the calculation for vertex A to B is 5 plus 5 plus 3 plus 3 plus 5 plus 5. So total is 26. For vertex B to D, 5 plus 3 plus 3 plus 5 plus 5 plus 3 plus 3 plus 5. So the total is 32. So for vertex D to E, 5 plus 3 plus 3 plus 3 plus 5 plus 5 plus 3 plus 3 plus 3 plus 5. So the total is 38. So the total weight for figure 2 is 96. For figure 3, we have a 6 vertex of Hamilton circles, and we need to calculate the weight 2 times at each vertex, same like a figure 2. So based on the diagram above, we can sum up the direction. It will be start with vertex A, B, C, D, E, F, and will be end with vertex A with the total weight. So for the calculations is vertex A to B is 1 plus 1 plus 1 plus 2 plus 4 plus 10 plus 4 plus 2 plus 1 plus 1. So the total is 27. So for vertex B to C, 1 plus 4 plus 1 plus 1 plus 4 plus 1. Total is 12. For vertex C to D, 1 plus 5 plus 1 plus 4 plus 1 plus 2 plus 4 plus 10 plus 4 plus 5 plus 6 plus 5. So the total is 48. And for vertex D to E, 5 plus 6 plus 5 plus 5 plus 6 plus 5, total is 32. And for the lastly for vertex E to F, F 5 plus 5 plus 5 plus 6 plus 6 plus 5 plus 4 plus 10 plus 4 plus 5 plus 6 plus 6 plus 5. So total is 72. So total weight for figure 3 is 191.
Assalamualaikum and salam sejahtera. I am Noril Atila binti Putra with number matrix CI220110. And now I'll be explaining my part, which is the coding and the output part. So let's go through all the coding part. So first for the class declaration, public class Hamilton circuit. So the class name is Hamilton circuit, indicating that it's designed to find Hamiltonian circuits in a graph. Second, we have the instant variables for private integer v, private integer graph, which is the v represent the number of vertices in the graph, and graph is an adjacency matrix to represent the connections between the vertices. Next, we have the constructor, which is the public Hamilton circuit integer v, capital V equal to smaller v, graph equal to new integer v and v. Constructor initialize the number of vertices v and creates an empty adjacency matrix. So next we have the adding edges. At the coding part, public void add edge integer v and integer w. Graph vw equal to 1 and graph wv equal to 1. The add edge method is used to add edges to the graph. It will update the adjacency matrix to indicate connections between the vertices. Okay, next, we're gonna find the Hamiltonian circuit, which is the public void find Hamilton circuit, and then proceed with the integer part, new integer, arrays.fill until the system.out.println Hamilton circuit does not exist. So the find Hamilton circuit method initialize an array path to keep track of the Hamiltonian circuit. And then it will call the utility method, which is the Hamilton circuit util, to find the circuit. Next, we have the Hamiltonian circuit utility at the private Boolean Hamilton circuit util, integer part, integer post. So, at the Hamilton circuit util is a recursive method that explores different parts to find a Hamilton circuit. Next, we have the self vertex checking at the private boolean is safe integer v integer post integer parts. So the isSafe methods will check if adding a vertex v to the part at position post is safe, to ensuring no repeated vertices, and that there is an edge between the last added vertex, which is the v. Next, we have the backtracking, which is at the path post equal to -1. So if the addition of a vertex doesn't lead to a solution, the algorithm backtracks by setting the path to -1 and will exploring other possibilities. Alright, next to the next section of the coding. Okay, now I'll proceed with the next section of the coding. So basically, next is the printing Hamiltonian circuit and the private void print Hamilton circuit in part. The print Hamilton circuit method will display the found Hamiltonian circuit in the coding. Next is the main method and the public static void main string. Hamilton circuit, Hamilton graph equal to new Hamilton circuit, which is the main method creates an instance of Hamilton circuit and add edges to represent a sample graph, and then calls find Hamilton circuit to find and print the Hamilton circuit. Alright, as you can see here, at edges for the example graph, we have 7 edges, which is the 0, 1, 1, 2, 2, 3, 3, 4, 5, 6, and 6, 0. And for the output, we will have Hamilton circuit 0, 1, 2, 3, 4, 5, 6, 0, which is in Hamilton circuit. We have the same first and last vertex. Alright, that's all the explanation for the coding and the output. Okay, now I will proceed with conclusion. So the code showcases the power of Hamilton circuit in optimizing circuit design. It systematically explores paths through a graph, ensuring each component is visited only once, and this has a significant implication for a circuit layout, allowing for synchronized cloud networks, compact boards, and minimize crosstalk issues. Leveraging Hamilton cycles can lead to a smaller, faster, and more efficient circuits, fostering innovation across various technologies. That's all from us, Hamilton Path and Circuit. Thank you.